colleges from Pune and other areas. Actually, it's a very good opportunity for me to introduce Mr. Jonas' work today because and also it's a good opportunity for me to introduce him because I also work in the same technology. Although Jonas wears a different hat of author, speaker, researcher, consultant, but I see Jonas as a thought leader and an innovative problem solver because he's one of the most active contact mind on the social media. He posts a lot of things on technology, implementation and control and communication and technology a lot. By profession, he's a subject matter expert in the digital transformation in process industries, technical adoption and digital architectures, for building some good dashboards and analytics and historians and everything, and which is used in the industrial IoT device management to build a digital ecosystem. He has over 30 years of experience in the field of information control. He is a senior member of ISA and participating in different standards committee like ISA 104 and 108. And he also, as Mr. Varga told, that he is a study committee member of Freecom Group in Asia Pacific. So he has written two books and contributed to several articles in Tech and all other publications. And he's also editor of ANSI ISA standards. And he also holds some patents in safety communication and also technical writer and more importantly, he's a designer. So over to you, Jonas. Very glad to you here in ISA Pune section. Please.
Thank you very much for that introduction. So let me switch. I'll start sharing mine.
Right. Thank you.
Right.
Recording is started.
Yeah. All right. Okay. So on that note, on creating a better world, through automation. Yes. Let's talk about wireless automation for sustainability. Imagine a green plant, a sustainable plant with no undetected leaks, no unaccounted for emissions, no undetected passing, no hidden fouling causing inefficiency, and no undetected overconsumption. This is this is critical to achieving corporate sustainability goals. And you can do this for your existing plants today, actually. So tomorrow, the 22nd of April, is Earth Day. So I will speak about three things. First, why plants change to become greener and more sustainable. Then how plants change, by transforming how sustainability management is done. And lastly, what plants change. They deploy more automation for sustainability management. That is, I will talk about the why, the how, and the what of automation for sustainability. So I will start with why plants change. The current reality in most plants is that leaks are not detected, emissions are not detected, passing is not detected, there's hidden fouling is causing inefficiency, and overconsumption is not detected either. This is why plants want to change. So how do plants change to fix this? Well, through transformation of work practices. Plants automate energy and emissions related tasks to become more sustainable, but also to reduce the burden on plant personnel with energy accounting, with energy cost allocated per plant unit to drive responsible consumption within the plant, emissions monitoring to detect greenhouse gases, health monitoring to detect failed equipment like steam traps and passing relief valves to stop energy loss like flaring, performance monitoring to quantify equipment fouling and optimize the time of cleaning, and real-time dashboards, to spot deterioration in efficiency early. So what do plants change? Well, they deploy more automation. Plants have long been run using KPI reports, but KPIs tend to be lagging indicators. To run the plant proactively, you need leading indicators. In a smart plant, the operations personnel now manage the plant from real-time dashboards with real-time indexes. So this makes them more responsive and proactive. For instance, the sustainability dashboard provides high-level overview of consumption, losses, emissions across the plant or multiple plants. So this real-time information drives quick corrective action, to help plants meet their sustainability goals and reduce energy cost. The information in the dashboard is automatically aggregated from underlying analytics such as emission monitoring systems, energy management information systems, equipment's performance monitoring, and health monitoring analytics. And it also saves time, not manually gathering data and compiling a report. Yeah? The exact dashboard content is personalized based on, industry and plant requirements. Now, first challenge, energy management with manual data collection has limitations. Plants do not have the utility metering data they need for effective energy management. Metering is typically only for the plant as a whole, as utilities like water, electricity, and fuel gas cross the battery limits into the plant, or as steam and compressed air comes out of the boilers and compressors. This is insufficient for or to fully utilize energy management software. Meter readings are infrequent, maybe monthly, quarterly, or even yearly, which means detecting and responding to high consumption or leaks is delayed. So, and more frequent manual readings would be too labor intensive. So the recommendation is to automate data collection. In-depth energy management requires in-depth data of how energy flows throughout the plant for the area and for each unit, and down to heavy energy consuming pieces of equipment in real time. So therefore, energy management starts with a foundation of real-time data collection, deploying additional flow meters for sub-metering on every branch down to unit and even equipment level. So sub-metering of every branch is key to all energy management software functions like the cost centers, the precision with which overconsumption is pinpointed, the granularity of reports and dashboards, and the precision of leak detection. All are determined by the level of sub-metering you're doing. That is, sub-metering is a key success factor for energy management. So don't overlook sub-metering. And other measurements required for energy management include pressure and temperature to calculate the enthalpy of steam, and other measurements for calorific value of fuel. Yeah? Now, various types of flow meters are required. Water typically using mag flow, compressed air using DP flow, fuel or other gases using DP or Coriolis mass flow meters, electricity, well, that is provided, from the motor control center and electrical switchgear. But steam, yes, using vortex or DP flow transmitters. Now, deploying sub-metering can be tricky because flow meters are mostly inline and therefore intrusive, meaning you must open a section of pipe, to insert the flow meter. So although this can be a challenge, this doesn't mean you shouldn't do it, because a software solution without granular sub-metering is not helpful. Now, in a batch operated plant, you can install inline flow meters during the idle time between batches. But for a continuous plant, you will have to install inline flow meters during the next turnaround or other outages or shutdown. So plan for that now. Mhm. A differential pressure flow meter with a compact orifice can be used for sub-metering on branches. It's very thin, so it can be like slipped in between flanges by prying the flanges between existing pipe sections apart. And DP flow meters are available in a wireless HART version, meaning power cable and signal wires need not be laid. Note that other wireless technologies may not have industrial grade DP flow meters. Also, smart magnetic flow, vortex, and Coriolis flow meters are wired for power, but since they communicate HART, they can be fitted with wireless adapters, provided you use the wireless HART networking technology. So other wireless technologies may not have wireless adapters, so be careful. Another plant challenge is that fouled equipment like heat exchangers, cooling towers, and air-cooled heat exchangers have lower efficiency, increasing energy consumption. But cleaning to restore performance is disruptive and costly. So the trick is to optimize the timing of the cleaning based on performance analytics. Now, manual performance monitoring has limitations in that it's time consuming and not real time. So the recommendation is to automate equipment performance analytics. A performance monitoring system includes a software piece plus automatic data collection using add-in sensors to understand what's going on inside the equipment. Once the inefficiency is detected, as indicated by the fouling factor, you can do something about it. You can determine the optimum time for cleaning to restore efficiency, to minimize energy loss, while also minimizing the impact of scheduled downtime or from capacity reduction. From the software, you can pinpoint the fouling to a specific bundle of a heat exchanger bank. Now, the analysis needs real-time data. The most reliable way for software to determine efficiency of equipment is to fully instrument the equipment. The inlets and the outlets, with temperature sensors, as well as flow meters and pressure sensors, depending on the type of equipment. Now, running wires in existing plants for lots of new sensors is not practical. Using wireless HART sensor is really the most practical way. Note that the required 4-in-1 temperature transmitters that you see here and industrial DP flow transmitters may not be available for other wireless technologies. Okay, and on a separate note, you don't have to develop, test, and pilot software. These apps are ready-made and support HART IP as well as OPC UA. So you can install and use them, just like that. Similarly, scaling and fouling of the cooling tower fill reduces efficiency, driving up energy consumption. Again, automation with software and sensors help determine the optimum time for cleaning or fill replacement. Injection of anti-fouling chemicals can also be optimized. This way, data drives energy efficiency and sustainability. Air-cooled heat exchanger fouling can occur on both the air side fins and tube side, reducing the efficiency, again driving up energy consumption. Now, using data from additional sensors, the software computes a fouling factor. This information is used to determine the optimum time for cleaning in order to improve sustainability while minimizing the downtime for cleaning and, in this case, can also be pinpointed to specific cells. A third challenge is that energy is wasted when steam traps fail blowing steam. Failure trapping condensate cause inefficiency and other problems. The trick is to detect it early. So manual surveys have limitations in that it's time consuming and not real time. And locations sometimes inaccessible. Yeah? And it can be as much as 1 year between inspections. Yeah? And the same is true for product loss through relief valves. When a pressure relief valve releases, you send valuable product to the flare, going up in smoke. Product is also lost over time when PRVs are not seating back properly after a release, creating a small internal leak passing to flare. It can be a small leak, but over time, it totals up to significant loss. So the recommendation is to automate steam trap monitoring with automatic data collection and analytic software to tell the health of these traps. Once failure is detected, you can replace them immediately. By getting data once a minute instead of once a year, you can minimize steam loss. This improves energy efficiency and sustainability. Again, these software apps are off the shelf, so no coding required. Again, wireless HART is the most practical way to deploy sensors. Similarly, the recommendation is to automate PRV monitoring with sensors and software. So you get a positive timestamp indication of when the release occurred and for how long, estimated release amount, and you know exactly which PRV is passing or releasing. Yeah? And you can correlate the release to process event leading up to the release. So you can make changes to prevent reoccurrence. That is, this is a flare reduction. It's also helpful for reporting. Well, when passing is detected by the sensor, you can overhaul sooner, thus minimizing product loss and flaring to become more sustainable. Greenhouse gas or GHG emissions is another challenge. We already spoke about safety venting and flaring from pressure relief valves. So let's look at other undetected methane emissions. Methane has a much higher global warming potential, or GWP, than carbon dioxide. So detecting methane emissions is important. The trick is to detect leaks early. Manual surveys have limitations in that it's time consuming and not real time. Since methane is flammable, explosive, there is a safety element to this as well. A wired 4 to 20 milliamp hour smart combustible gas detector can be used, for methane detection. It can be fitted with a wireless HART adapter, just like wired flow meters, to enable wireless transmission of measurement data and for configuration and diagnostics as well. Again, one of the reasons why wireless HART is so popular in plants is because it supports these HART adapters, which most other wireless sensor network technologies don't. Well, as you can see, we have there are two main parts to the additional automation required for digital transformation use cases. The pervasive analytics for automatic data interpretation using monitoring and optimization apps, and pervasive sensing for automatic data collection using MNO sensors. Remember, before you can connect the dots, you have to collect the dots. Not all use cases need analytics though. In many cases, measurement and alarm is sufficient. Plants have lots of data, but it's mostly process data, which is not sufficient. You can't solve equipment problem using only process data. You also need equipment data, hence the additional sensors. As an additional bonus, once you automate the data collection in the plant, you also enable people to work from home a few days a week. Analytics need real-time data for prediction, so manual data collection must be automated. Instead of a portable temperature gun, there is a permanent transmitter for temperature. Instead of portable ultrasonic thickness tester, there is a permanent UT sensor for corrosion and erosion. Instead of portable vibration tester, there is a permanent vibration sensor for that. Instead of portable acoustic tester, there is a permanent acoustic sensor for relief valves and steam traps. Instead of mechanical pressure gauge, there is a permanent wireless pressure gauge for that. And this is why having a wireless HART infrastructure in the plant is so important. You need wireless sensors, and you need a wireless technology for which all of the industrial grade sensor types are available, including differential pressure, radar level, 4-in-1 temperature, as well as wireless or HART adapters and all the rest. Many wireless sensors come with an associated app, but that's not sufficient. You also want to get some of the measurement data into third-party analytics and other software. For some use cases, you also want to get the data into the DCS or historian because operators need to know. The wireless gateway must make measurement data available as OPC, UA, Modbus, and HART IP. Now, many wireless sensor network technologies require scripting and coding to extract the measurement data. This is costly and time-consuming to deploy and challenging to support long-term. Such wireless technologies are not suitable for plants. The wireless HART technology, on the other hand, enables gateways to automatically convert measurement data to OPC UA, Modbus, and HART IP without coding or scripting, which is one of the many reasons why wireless HART is so popular in the process industries, because integrating the data is so easy. All right. So to conclude these slides, let's recap before we move on to the demo. So I spoke about three things. First, why plants change to become greener and more sustainable. Then how plants change by transforming how sustainability management is done. And lastly, what plants change. They deploy more automation for sustainability management. That is, I spoke about the why, the how, and the what of automation for sustainability. Well, tomorrow is the 22nd of April, Earth Day. So start transforming your plant already next week. Okay, so with that, it's time for demo. So first, I'm going to do a software demo. Yeah? Maybe we can mute Himanshu there. Okay, so let me switch to this software here. Just give me a second. Oh, let's see, duplicate. How does that look? All right. Okay, so this is what the analytics apps actually look like. So you can see it's kind of just like the apps that you have on your smartphone or tablet, if you will. So if you want to monitor steam traps, you use the steam trap app. If you want to monitor heat exchangers, then you use the heat exchanger app. If you want to monitor relief valves, there's an app for that, and air-cooled heat exchangers, cooling towers, and so on. Okay, so let's take a look at steam traps first. Okay, so you can see in this plant, I'm monitoring 100 steam traps. And I can see 11 of them are blowing steam and 9 are cold, trapping condensate, okay? Both are bad. So I can zoom into greater level of detail. So I get a summary, an alarm summary, but it's not process alarm summary, it's an equipment alarm summary. And I can see here on asset status, I can say these are the ones that are blowing, are blow through. And then I can see here, okay, these ones are the ones which are plugged, trapping condensate, okay? So this is descriptive analytics, you know, it tells me which steam trap has a problem and what's going on, okay? And it also tells me what is my energy loss and the carbon footprint that it's causing, right? Okay, so let me take another example. I'll move this out of the way. We'll go back here. Let's take a look at heat exchangers. You know, again, all plants kind of have heat exchangers. Yeah, so I can see. Okay, I'm monitoring 48 heat exchangers, and 2 of them have a warning. Yeah, and you can see, but yeah, most of them are good. I don't need to spend my resources on those, but some of them are warning, and there's also a description of what's going on. Yeah. So now we can actually take the opportunity here to zoom into one of these, you know, and if I go down here to the bottom, I can actually see here, you know, what is the fouling factor, the losses, the duty, you know, and the change in heat transfer coefficient, etc. All of that information is now calculated for me. So it brings in data from the underlying sensors. Okay, so here on this page, you can see let me see if I get right. You know, the various different sensors where the data comes in, and you can see here through the wireless heart sensor. You know, the data is coming in. All right, that was not a good example. Let me look up another one. Let's look at the cooling tower instead. You know, that's a good idea. Oh, over here. So I use the cooling tower app. Right, so I got 10 cooling towers, you know, 4 of them are in critical condition. Let's zoom in and take a look and see what they are. So all these are good. I don't need to waste my time on those. These are the ones with critical issues, you know. But anyway, let's take a look at one of these here. Let me see, yeah, look at the device details. And so here I can see that in this particular one, yeah, this measurement, this flow measurement is coming in through Heart IP, but I could also configure it, you know, to OPC UA. Let's say if the data comes in from through my existing DCS or historian, you know. But yeah, if it's a wireless heart device, the data will come in through Heart IP. And if you're familiar with heart, you will also recognize this, you know, primary variable, second, tertiary, and quaternary variables, you know. So multiple variables can be accessed from the heart device this way, you know, wireless heart transmitters. Yeah? And I think you get the concept, you know. So depending on what you're monitoring, you know, there are also apps, you know, for pumps and corrosion, you know. So these are all about predictive analytics, you know, so that you know what's going on, you know, and you can detect or predict pump failure in advance. Okay, next, I want to we're going to switch over to my mobile camera so that we can take a look at yeah, some of the hardware, the wireless sensors, and the gateway. Okay, so I'm going to stop sharing here for a moment, and I'm going to switch over to the other camera. So just bear with me for a moment. Yeah? Stop. And Right, okay, so this is Jonas again. Let me turn my camera on. I'm gonna turn it around first. Start my video. All right, can you hear me okay, guys?
Yes, we can hear you.
Yes.
All right, excellent. Okay, so let me show you around the solution center here in Singapore. So first of all, well, so here is an example of the dashboard that I spoke about. So this is a sustainability dashboard. That shows you at a glance the emissions, overall efficiency, etc. And emissions going on in the plant by energy stream. Yeah. Oh yes. Also, what I wanted to measure, right? Mention that if this is the first time you use WebEx, what you can do to make this video feed larger, okay? Right-click on the video feed from me and select move to stage. That's the option there with a little pin. So move to stage, and then you can drag the little white bars which is on the left and on the top of the video. You can drag those, and thereby kind of maximize the video from me. So then you can see more clearly what is going on. Okay. Right. So yeah, right click, select move to stage, and then drag the little white bars to maximize. All right. Okay, so then, so in the solution center then, yeah. So here, yeah, we got the video wall, and well, there's the analytics, and you can also get detailed vibration spectrum, if you're dealing with vibration. But also what I wanted to highlight is, intelligent device management, like the good old AMS device manager. So you have all of these wireless HART devices. You can also manage wireless HART devices from the same software that you use to manage your wireless, your wired 4 to 20 milliamp devices and your field bus devices. All right. So with that, let me just walk you into the plant. I'll have to walk through our center here. That's the workshop area, but we're not doing a workshop today. This is the VR area, but we're not doing a VR today. Okay, so this is the plant. Over there is the local control room, but we'll save that for another time. So what I wanted to show you today is, for the sub-metering, which is so important, for energy management, you can use Coriolis flow meters, so that is a 4-wire transmitter. And down here, we have a 2-wire Coriolis flow transmitter. And as you can see here, it's fitted with the wireless HART adapter. So even though this is a 2-wire device, with loop power to power the sensor or the measurement tube, we still have wireless data transmission through the wireless HART adapter. Okay, and remember, or HART adapter, if you will. Remember, wireless HART is really one of the few protocols out there for wireless sensors that support HART adapters. So the other thing that I spoke about was what do you call it? DP flow sensors, right? So here's a DP flow meter, and this one is using the compact orifice. So this is the orifice plate here, and as you can see, it's only 25 millimeters or 1 inch. So we actually managed to insert it here simply by prying these flanges apart and slipping in the flow meters. Okay, so not entirely non-intrusive, but still very, very easy to install, without cutting, drilling, or welding. Yeah? Down here by the floor, you can actually see a steam trap, and you can also see a sensor on that one. So this is a wireless heart acoustic sensor. It's really a two-in-one sensors, both acoustic noise and temperature, And so these values are then sent to the steam traps analytics that I just showed you, and that then determines the health of the steam trap. So typically you used to go here and inspect once a year, but now you get an update once a minute, so you can immediate notification. So instead of the steam trap blowing steam for maybe 6 months or a year, you can replace it immediately. So you can see how you can reduce steam loss this way. Anyway, so the analytics that I just showed you, it uses the acoustic data and the temperature data to determine the health of the steam trap, whether it's blowing steam or trapping condensate, or most likely functioning well. And it really works for any type of steam trap. Now, the next thing I wanted to show you here is a PRV, pressure relief valve, which is a very important safety device. Again, it's also been fitted with an acoustic sensor, which is wireless. Yeah, it's the same sensor as we have on the steam trap. Again, as you can see, this one is actually non-intrusive. It simply clamps onto the outside of the pipe. No cutting, no drilling, and no welding, So you can install this type of sensors on your relief valves and your steam traps today. No need to wait for any shutdown or anything like that. You can do it now. Okay. So these are some of the sensors that I actually spoke about in the presentations required, to achieve this use case. Now over here, so this is the wireless heart gateway, and I think up there you can also see the radio. So and this wireless heart gateway, it also supports automatic conversion to Heart IP, OPC UA, and to Modbus. Okay, and that makes it very, very easy to integrate the data into all kinds of data lakes, historians, into your DCS or PLC, into dashboards or analytics, and so on. Okay, so makes it very easy to use the data. Again, other wireless technologies do not automatically convert data to other protocols this way. Well, so here in the Solution Center, we also have all kinds of other wireless heart devices. There are vibration sensors, there's corrosion sensors, there's wireless pressure gauges, H2S sensors, safety shower monitoring, position sensors, radar level transmitters, and wireless level switches as well. And all of these wireless devices, whether they are used for sustainability or reliability or for safety or to, improve production, they all use the same shared infrastructure. That same wireless heart gateway, it supports all of these different sensors. So, okay, well, yeah, that's all I wanted to share today. I don't know how we are doing on time. Is there any time for Q&A here, or I think we're actually running over by a little bit because I think we started late.
No, we have 15 minutes.
Okay.
We can take some questions.
Sure.
Yeah. So maybe, I don't know, if people have submitted questions through the chat box, that might be the best option here. So type in your question in the chat, and then maybe Harish or our host can read it out. Because if we open up the line to everyone at the same time, I think it's going to be a challenge. Yeah. So
Jonas, there are already some questions which have been posted.
Excellent. Let's go.
Can